I'm here to talk to you a little bit about nuclear power. I believe personally that the ability of people to harness the power of the atom for civilian uses is probably one of the greatest achievements that mankind has made today. According to the International Atomic Energy Agency, over 14% of the world's nuclear power, or world's electricity, comes from nuclear power. Today I'd like to go over the history of it, how it works, the pros and cons, and the future of nuclear energy. Back in the 1930s, a scientist named Enrico Fermi discovered nuclear fission. He later created the world's first nuclear reactor in 1938. This technology was used to develop the first nuclear weapons used in World War II. After World War II, the United States created the Atomic Energy Commission, which is basically an organization used to study nuclear energy and its possible applications for civilian uses. The first generated electricity made by nuclear energy was made by a nuclear reactor in 1951, and 3 years later, in the Soviet Union, the first civilian nuclear reactor was put online. A few years later, in 1957, the United States made its first nuclear power plant in Shippingport, Pennsylvania. And this growth continued until the early 1980s, when concerns about safety, nuclear waste, nuclear proliferation, and costs caused the U.S. to cease construction of nuclear power plants, and the last power plant made in the U.S. went online in 1997. I'd like to go over a little bit about how it works. When you have a nuclear material like uranium or plutonium, and you fire a neutron at it, it hits the nucleus and causes it to split. This split creates heat in the forms of kinetic energy, or gamma rays, and radioactive decay. This all occurs inside the reactor, which is surrounded by a coolant, which has always been water. And this water absorbs that heat and begins to boil, which creates steam. And this steam is very, very high pressure and causes turbines to spin, which generates electricity. Also surrounding the core are control rods, which is material that absorbs neutrons and can speed up or slow down the nuclear reactions. In theory, as long as the control rods work properly and the coolant does not get too hot, then there will be no problems with nuclear energy. Now you might be wondering, what's so great about it? Why do we take all these risks for it? Well, for one, it's much more efficient than coal or gas. According to the University of Washington, 1 ton of uranium-235 generates about 2 million times more energy than a ton of coal. It's also a very secure fuel source. According to the International Atomic Energy Agency, there are about 3,000 years worth of fuel available at current levels, compared to about 200 for coal and less than that for oil. It also does not produce any greenhouse gases, which is a lot better than coal and gas-fired power plants. And we all know that today global warming is a huge issue. But you can't say that there are no drawbacks either. And even though it doesn't create any greenhouse gases, it does create very dangerous radioactive waste. Waste that we have not really found a way to take care of yet. We've proposed building storage sites in mountains or deep underground, but nobody has really found a good way to keep it secure for thousands of years. There are also concerns about nuclear proliferation, which is basically either rogue nations or terrorist organizations taking this nuclear waste and being able to refine it to make a weapon, whether it's a nuclear bomb or a dirty bomb. And that's a concern that has to be taken care of, because although nuclear power plants are quite secure, according to the International Atomic Energy Agency, a lot of nuclear fuel processing sites are not very secure. Another major issue are the costs associated with building nuclear power plants. It is much more expensive to build a nuclear power plant than a coal plant or an oil plant, largely because of the risks associated with it. Looking ahead, a research study done by MIT in 2003 and later 2009 concluded that the United States ought to build less expensive reactors in order to lower overall costs, but that they should continue building nuclear power plants. They also believe more research ought to be done on coolants in order to increase safety, and they also believe that nuclear fusion should continue to be looked into. Nuclear fusion is what happens in the sun, where instead of splitting an atom, 2 atoms are slammed together to create the same heat that you have in a nuclear power plant. It is much safer and produces almost no waste compared to nuclear fission, and it could be a viable option in the future. Nuclear power has no doubt come a long way since the 1930s, when it was literally just a pile of uranium sitting in a lab in Chicago. And I believe that with the right research and money and dedication, we can find a solution to the current looming energy crisis that's both clean, safe, and cheap. Thank you.
All right.